Hey everyone, welcome to the second series. I am the Flip-Flop Fabricator, and this time we're going to build a Power Wheels mini truck. And here's what I got. This is a 12-volt Power Wheels Chevy Silverado. It comes equipped with an AM/FM radio, bucket seats for a couple of 8-year-olds, and functioning headlights. I picked this unit up for $200. The Silverado will be mated to this, a Kazuma Falcon ATV. It has a 250cc engine with an automatic CVT transmission. Previously, the wire harness was on fire, and the plastics were completely removed. The engine turns over, but there's no carburetor. I was able to get this beast for $300. So there it is. We're going to use the Chevy Silverado Power Wheels as the body, and we're going to use the front suspension, the cooling system, the brakes, and the swing arm from the ATV. But first, to get the body ready, we're going to have to take the Silverado from this to this. After breaking down the Power Wheels, it's time to chop the body. Most of the plastics inside where the seats go, underneath where the dash sits, and under the hood all has to be cut out. And the answer to the question, do my feet get covered in molten plastic? The answer is yes. With the Power Wheels body cut to fit, I now turn to the frame of the ATV. Alright, so I've taken the top section of the frame off. This is where the handlebar section would come into the lower mid part of the frame. So all that's actually just laying over there. And yeah, so I moved all that, keeping the original front suspension mount points and even the original plastics bracket. This is actually going to help hold the body on, which is now laying up there. And then moving down, I just removed the rear shock mount area. So this is kind of the back flare piece, which is now there. It's like where the back of the seat would sit, and then the upper shock mount would be about right here. So I don't know how exactly I feel about this plan. We're gonna see how it goes. I've ordered 2 mini bike rear shocks, a pair of rear shocks. They're meant to be mounted as vertical swing arm shocks on each side of a mini bike or pit bike. I'm hoping the 2 of them combined can support this rear swing arm in a vertical position, because the shock that's on it is 17 inches long from this point up to its mounting point, and I need this whole back end to get lower. Alright, so here's the motor from the ATV. I started taking it apart, some things that I want to look into. I want to check the piston, I want to check the valves. Some of these gaskets need to be replaced because they look like they've been blown out. It leaks oil for sure. I did drain the oil. The oil did come out clean. I mean, it was filthy and black and just old, but didn't have any water in it, so hopefully the head gasket's good. Didn't have any large pieces of bearing material or any type of metal, also good. The bottom, the magnet on the bottom of the drain plug looked okay. They're just the standard wear metal, the little filings you get, but nothing alarming. The water pump definitely looks like crap. A whole bunch of rust and old gunky water came out. The O-rings are all completely gone. These hard lines are all in pretty good shape though, and some of the major stuff looks okay. Starter even seems like it might work. But the biggest problem is the wiring. So the wiring on this entire machine was absolutely cactus. And a lot of what I'm talking about is like right here. So this is all melted coating and the wires are all exposed. Now this has happened in a couple of places, and even inside the plug, it's just melted. So I'm a little concerned that this thing was oversurged, that either the wrong battery was hooked up to it or there was a fault in the rectifier. Something had to have happened because in more than one place the wires have been melted. So what I want to do today, part of this little series this time, is a little bit of a how-to and some quick diagnostic type things you can perform on your own with some very simple pieces of equipment. So we're going to get into that next, and what we're going to do is we're going to start testing the electrical system from front to back on this ATV to find out where the problems are and what it's going to take to fix it. And then eventually we're going to get to building a wire harness. So all right, let's dig in. Okay, so the first thing we want to talk about, not sure how familiar you guys are with these systems, but basically every electric starting ATV, dirt bike, moped, whatever small vehicle side by side, it's going to have a stator inside. And a stator is basically just a multi-spoked circular disc with wire wrapped around it. And that electrical wire gets passed by a magnet, and that's usually on the permanent magnet on the magneto, and that will induce a current. And that will generate a current which will charge things like charge your battery. And generally this is a really convenient, packaged, lightweight way to generate small amounts of electricity to keep small machines operating. Now, the rectifier, its job is to translate the power coming out of the stator, which is coming out as alternating current, or AC, and it needs to change it into direct current, DC, which powers all of your devices on the machine and charges the battery. So this is the first step in the process after the power comes out of the stator. It comes down along these wires here, and typically you've got a couple, there's a few different variants of stators. This is what's known as a three-phase stator, and you can highlight that by the three common yellow wires. Sometimes they're white. I think they might use black too. But you're going to have three common color wires, and that tells you this is a three-phase stator. All right. So likewise on your rectifier, if the plug was still there, you would then have a 3-pinned plug with those three yellow wires. So you got all three in there. Okay. This goes into the rectifier regulator, and what this does is it, as it says, rectifies the current problem. So you've got an AC problem, you need to get to DC. And so in here is a series of diodes, and that allows the power to change over to DC. So you can charge all your devices, run your lights, do all your other things on your machine. So there's a good way, an easy way to test this, and all you're going to need is one of these. So let's go ahead and set up our test. All right, so got my multimeter here, and this is just the Harbor Freight multimeter. It's like $4 or something. And this will work perfectly fine for what we're trying to do. The thing you want to set your multimeter to, the setting, is this one right here, if the camera will focus on it. This is the diode test setting. You can also do the same test using resistance. I don't recommend it. It's sometimes a false positive test. There's different things to keep a lookout when you're using a resistance test for diodes, but in this case, we're going to use the diode setting. It's the proper one. It's the best way to do it. All right, so we're going to go ahead and turn our multimeter on, and you're going to take your regulator rectifier, and you're going to find the 3-wire plug. You'll probably have another plug for for the outboard going out of the rectifier, the regulator, but we want the 3 same colors. So again, it's either going to be white, yellow, black, but you're going to have 3 identical colored wires. That's the plug you're going to want. So what you're going to try to test here is you're going to test whether or not the diodes have failed. And I've already kind of done this off camera, so you're going to get to see today what a good diode will look like and then what a bad one looks like. Now we want to move over to the outward plug, which has 3 different colored wires. And you're going to notice in this case, it's black, red, and green. All right, so we can start at either the black or the red. It doesn't matter which one, but this is for directional purposes. So you're looking at the forward and reverse direction, and you're going to try it in both directions on the multimeter. So what you'll do is we'll start with the red. So we'll find the red pin on this connector, and we'll take the black lead and we'll stick it inside this connector. Get a good contact. Okay. Then you want to take the other probe from your multimeter and start testing the individual pins on the stator side. All right, and this would be coming out of your engine, right? So the stator wires come off the engine and plug into this. So we start connecting them into the pins, and we get a reading. Now I'm going to try and set this up better so you can see it. Okay, and so the first reading we get is right around 473, 474. So what you're looking for is a voltage reading between 0.3, I believe it's 0.3 to 0.8 volts is acceptable on a standard graphite diode, silicon diode, excuse me. And what we're getting here is between that range. So 472, that's a good value. In this direction, the diode is working. We move on to the next pin, and we're going to test all 3 pins in the same way. And it looks like, okay, we get 469, very close to the previous one. That's really good. And we check the third one, and 49. Excellent. Okay, so we're pretty much all in the same range. Now, if there's a failure, you're going to get that. Or in some multimeters, it says OL, or outside limits. That means your diode has failed and your regulator is junk. All right, so now we've tested it in that direction. Now we're going to switch. Now looking at it in the opposite direction, all you want to do, pull the lead out and change lead colors. So now red to red this time. So we're going to get the red one in there. And now, since we're looking at it in the opposite direction, you want the opposite effect. Now we don't want anything to show up on our screen. We want it to stay as OL or that giant 1. So we're going to go ahead and go in and check it. Good. Check the other 2. Good. And third one. Good. Perfect. So this is what we're looking for. All right. Now you're going to take the red lead back out, and we're going to switch to the black wire. So find the black wire on the plug, find out what pin that's in, and that one looks like it's right here. And we're going to start with the black lead. Now, if you recall, when we did the same color on the red, red to red showed up as a 1 or an OL, depending on what multimeter you're using. Oops, sorry. And when we did the opposite color, so when we did red to black, we saw a voltage across it, okay? So because we're doing same color, we should expect that one to not change. So we'll go ahead and pick up our stator side wire, and we will start testing these probes, these pins. All right, so nothing there, nothing there, and nothing there. Great. So that works, okay? So now we're going to switch. So now black wire, red probe. We're going to do it in this direction. Okay. And now we're looking for a reading. Now we want to see again that 470 number, that 0.4 volt, 0.3 to 0.8 or 0.5 or something. But that's what we're looking for this time. Stick this in. And as you can see, I'm getting no reading off of that pin. Let's try the other pin. Nothing. Other pin. Nothing. Okay, so in either direction, I'm getting no reading. So that means this diode is in open condition, and that is a bad regulator. So unfortunately, this one is not going to work for us. So that's going to do it for the first episode of the Senderado project. I hope you guys enjoyed it, and if you plan on tuning into the next episode, please subscribe. As always, wear your flip-flops, LS swap the world. We'll see you next time.